Hello, I'm Steve Smith, aka R. Dallas, and today I'm going to show you how to expose a web API that will allow other programs to work with your ASP.NET Core application. We're going to use Visual Studio Community 2019, which you can download for free if you haven't already. Let's get started. To begin, I'll launch Visual Studio Community 2019 and return to the project I created in the previous video. In the last video, I created a simple app to manage my library of board games. Now, I'd like to expose this using a web API so that other applications like mobile apps, console applications, Angular or React single-page apps, universal window apps, or really any application that can access the internet would be able to interact with my app. So far, my application uses Razor Pages to display data and let users manage my game library. Razor Pages are great for this kind of thing, but for an API, I want to use a controller class in its own folder. I'll go into more detail about what a controller is in just a moment. I'm going to put all of my API-related functionality into an API folder, so I'll start by creating that in the root of my project. Then, I'll right-click on that and add a new scaffolded item. Next, I choose API Controller with Actions using Entity Framework as the next option. This will let me reuse the EF Core DB context I created in the last video. Now I just need to choose my game as the model class, and otherwise leave everything as default and click Add. After a moment, a new Games Controller class appears in the API folder. Controllers are classes that contain methods known as actions. Each action corresponds to a specific route. A route is the last part of the URL used to interact with your app, along with the kind of HTTP request being made. I'll get into that more in a moment. Razor Pages use a simple convention for their routes, such that wherever the page is in the Pages folder, and whatever its name is, that's the route. Controllers typically use similar conventions, but they're defined using attributes in the controller itself. In this controller, the route is specified by the attribute on the class, which currently goes to API/whatever the name of the controller is. In this case, games. Each action will further add to this route, specifying the kind of HTTP verb it will respond to and any additional parts of the URL that it might need, such as adding an ID parameter in the case where the API should return a specific game record. In addition to the route attribute, the class also has this API controller attribute, which you should add to any API controller you create. It provides some helpful automatic validations and ensures that each action method uses an attribute for its route. The controller uses our Entity Framework Core AppDB context to work with the database. When the framework creates the controller, it's going to pass an instance of AppDB context into its constructor that will then be available for any action method to use. The first method here, which is decorated with an HTTP GET. The first method, which has a route that responds to GET requests using the /API/games route, returns a list of games. You can see it's quite simple, just a single line. It specifies the verb HTTP GET, and it returns the games collection from our DB context. If someone needs to fetch a specific game using its ID, then this next method is useful. Now the route needs to include the ID of the game. The addition of the ID parameter is made both in the route specified with HTTP GET and as a parameter on the action method itself. Wrapping the name of the parameter in curly braces inside the route is what allows it to map from the route to the parameter on the method. Inside the method, this action checks to make sure the input is valid, then tries to find a game with that provided ID. If it can't find one, it returns a not found result, and otherwise it will return the game record. The API will let you update an existing game by using the HTTP put verb and once more specifying the ID as part of the route. For this method, the new game record that you're going to update the value to is provided in the body of the request. This method has a little more logic and error handling than when we just looked up a game, but if it's successful, the record is updated in the database and otherwise an error is returned. Moving on to the next method, we see that we can use an HTTP post verb to post a game to our API. Post typically corresponds to creating a new record, and that's what's happening here. If the request is valid, then the new game that was provided in the body of the request is added and saved to the database. A link to this new game record with its database-generated ID is then returned, along with the game record that we provided, but now with its ID specified. Finally, deleting a game is done using the HTTP delete verb and providing the ID. If the ID in question doesn't exist, then a not found result is returned. Otherwise, the record is deleted. Now, let's test this API. To do that, we're going to install some new middleware that will provide documentation and some testing tools. The middleware is called Swagger, and it's generated using a tool called Swashbuckle. We'll add it using a package manager called NuGet. Right-click on the project, choose Manage NuGet Packages, click on Browse, and then search for swashbuckle.ASP.NET Core. Click on the item and choose Install. Next, open startup.cs. We need to wire up Swagger services and middleware. You'll find the code you need in the ASP.NET Core docs, and you can also just follow along with what I add here. First, inside of the configure services method, we're going to add SwaggerGen services. We also need to add any necessary using statements, which we can do by using the Visual Studio shortcut Control-, and then specifying that first entry there. We want to accept using swashbuckle.ASP.NET Core.Swagger. We just hit enter. Now in the configure method, we need to add middleware just above useMVC that will serve the generated Swagger JSON endpoint. And then similarly, we need to add additional middleware that will provide us with an HTML user interface that'll let us visualize and test our API. Now we're ready to run the app and work with the API. In the address bar, add Swagger and hit return. You'll see a list of API endpoints and the model types that they use. If I expand the first get, which will return a list of all games, I can see that it doesn't require any parameters and it should return a JSON formatted array of games. Clicking Try It Out shows me the blue execute button, and when I click that, the server response shows me the current list of games in the database. In this case, there's just one, Pandemic. I can add a new game using this post endpoint. Clicking Try It Out, and then modifying the template that's provided that gives me the model for the game to include some sample data. I don't need an ID for a new record. Clicking Execute successfully adds the game, giving it a new ID. In response, I get the updated record with its ID, as well as a link to the record in the API. Looking at one more endpoint, we can see the getByID method here. When I click Try It Out, I can specify an ID for it to search for. I'll use the new ID that my new record just was given. Click Execute, and we can see that the record is returned. The put and delete verbs work similarly. Now that I've created an API for my game library app, I can start using it to wire up rich Angular or React SPA applications or a cross-platform mobile app using Xamarin. To do that, I'll want to host it live on the internet. So in the next video, we'll look at how easy it is to publish the app to Azure directly from Visual Studio 2019 so that we can start to use it. Once that's complete, the only thing that will remain for us to have a working application will be to lock down who can use the app using some kind of authentication strategy. See you next time.